Operators in our language. An operator is a symbol to perform specific mathematical or logical manipulations. And R is rich in built-in operators. We have some examples here: arithmetic, relational, logical, assignment, and miscellaneous. We start with arithmetic operators. Arithmetic operators: plus, minus, multiplication, and division. Look at that example, addition. So we have two vectors, V and T. What are the elements of V? 2, 5.5 and 6. Elements of T, 8, 3, 4. So print V plus T means the first element of first vector is added with the first element of second vector, and the second element of first vector added to second element of second vector, and so on. 2 plus 8, 5.5 plus 3, 6 plus 4. Similarly, minus, subtraction, multiplication, and division. Look at division. 2 by 8, 5.5 by 3, 6 by 4. See the symbols percentage, percentage. In C and C++ and Java, we use percentage symbol to get the remainder, modulus. Here we use percent, percent. So 2 mod 8 and 5.5 mod 3 and 6 mod 4. So to get the quotient, we use percent slash percent. We use only slash in C, C++, Java to get the quotient, but here we use percent slash percent. Exponent, the first vector raised to the exponent of second vector. The next category is relational operators. Each element of the first vector is compared with the corresponding element of the second vector, and the result is Boolean value, either true or false. Greater than, the first element of first vector is greater than the first element of second vector. 2 greater than 8 is false. 5.5 greater than 2.5 is true. 6 greater than 14 false, and 9 greater than 9 false. Similarly, less than, each and every element of the first vector is compared with each and every corresponding element of the second vector. Equals to, less than or equal to, greater than or equal to. See the examples. Not equal to. So we have logical operators. Each element of the first vector is compared with the corresponding element of the second vector, and the result is a Boolean value. All the numbers greater than 1 are considered as logical value true, 1 and greater than 1. So we have AND. It combines each element of first vector with the corresponding element of second vector and gives the output true if both the elements are true. If both are true, then only the resultant is true. Look at the example. 3 and 4 is true. 1 and 1 is true. True and false is false. 2 plus 3i and 2 plus 3i is true. So we have logical OR. If one of the elements is true, you get the output true. If any one is true, then the resultant is true. Logical NOT takes each element of the vector and gives the opposite logical value. Look at the example. Not 3 is false. Not 0 is true. And not true is false. And not 2 plus 2i is false. So we have logical AND OR. Look at the symbols. 2 symbols, ampersand, ampersand, similarly 2 OR symbols. And these logical operators considers only the first element of the vector. Only the single element, first elements. Logical AND takes the first element of both the vectors and gives the true if both are true. It takes the first element only. Similarly, logical OR. So we have assignment operators. We have various assignment operators to assign values to vectors. You can see the examples. So even we have a right assignment. You see the examples. So we have miscellaneous operators. The first one is colon operator. It creates a series of numbers in sequence for a vector. Look at the example 2 colon 8. 2 colon 8 means you get a series of numbers from 2 to 8. And we have percent in percent to identify if an element belongs to a vector or not. So look at the example V1 percent in percent T. What is T? T is a range of elements, a sequence of numbers from 1 to 10. So V1 percent in percent T. Is 8 in T? True. What about V2? 12. Is 12 in T? False. Percent multiplied by percent. To multiply a matrix with its transpose. See the matrix 2, 6, 5, 1, 10, 4. Number of rows 2, number of columns 3. And T is equal to M percent star percent T of M. To multiply a matrix with its transpose.